Good morning. Today we're going to take a look at how we begin some of these more apparently difficult math problems on the SAT. You can see this problem came from, again, the official SAT study guide published by the College Board. It came from page 400 and it is number 17. So seeing that it's number 17 tells us that it's considered one of the more difficult ones inside the section. The math on this SAT, as we've said in our other videos, is not difficult at all. None of the math is difficult. The difficult thing is how they present it. What they do is they use a single principle of math in each of these problems, and as the problems apparently get more difficult, they're using either principles that you come on in later math courses in high school, or they start sort of nesting their principles together. And by principle, I mean just sort of an area of math. Like, what do I want to find out that you know as a math student? So in this particular case, again, this is number 17, so I know it's a more difficult one. Just looking at the problem, it looks a little difficult, but let's read it and see what it's really asking us to do, and then we can see what we need to do in order to break down or unpack this problem and get the information we need. So in the right triangle, ABC above, EF is parallel to AC, and F is the midpoint of BC. So see how they're giving us all these directions that are actually giving us the directions to unpack the information we need. Now this is the real question. What is the area of the shaded rectangular region? Now that seems to be a very simple principle. Again, the first thing we want to ask ourselves whenever we don't know how to start a problem is, what is the basic principle of the problem? So the first principle they're asking is the one that's right in the front here for us, right in the very surface, is the area of a shaded rectangular region. We know that the area of a rectangle is the length times the width. So it seems fairly straightforward. In order to get the answer to this, what's the area of that shaded region, we just have to be able to find the length times the width of this rectangle. So how do we do that? We have to unpack the information. So let's take a look at what they've given us, and we'll uncover some of these other principles that we have to know. Again, these principles give us the basic identities that we're going to use. An identity is any formula, something like the area of a circle is pi r squared, or in this case the area of a rectangle is length times width. That's an identity. And the other way we could think about it is as tools. That is, when we find out the principle, we find out what basic mathematical tools we need to use. So in this case, they give us a right triangle, so we know the tools we're going to be able to need to use are related to right triangles. They tell us that EF is parallel to AC, and F is the midpoint of BC. Now let's start by unpacking some of these things and using some of our tools. As soon as they tell us that F is the midpoint of BC, well, they've given us the length of BC, notice, and they say that that's 10 radical 2. So the first thing we need to do is to split 10 radical 2 in half, and that's 5 radical 2. So each of these segments is 5 radical 2. Now they tell us that this is also 10 radical 2, and since these are parallel to each other, we know that each of these is also 5 radical 2. Now, what else can we find out from this? If these lines are parallel, we can unpack from those parallel lines with a transverse coming across, and this is another principle of this particular problem, is parallel lines. Spell it correctly, is that this angle is exactly the same as that angle. And since we know that this is a 90-degree triangle and both of these sides are the same, notice this is another basic principle, which is the principle of isosceles triangles. I spelled isosceles correct. Isosceles triangles. So when the sides are the same, we know that these angles are the same. If that's 90 degrees, then those must each be 45. And that's another basic principle they've packed inside this problem. Again, it's number 17, so they've packed in a number of different principles. In this case, we have to know the basic identity for a 45, 45, 90 triangle. Well, what is the, and I'll just label that so we can see very clearly that that's 45 degrees. What is the identity for a 45, 45, 90 triangle? Well, you'll find this right at the front of your SAT math section, but where there's a 90-degree angle right here, and each of these sides is exactly the same. That gives us a 45, 45, 90 triangle. And the ratio of sides is x, since they're exactly the same. And this hypotenuse is x radical 2. So every right triangle that you have that has 45, 45, 90 degrees, it has a ratio of sides of x, x radical 2. Well, in our unpacking, we see that this is also a 45, 45, 90 triangle. And if that side's 5 radical 2, then we know that that side has to be 5. That is in 5, 5, 5 radical 2, again corresponding to x, x radical 2. So if that side's 5, and this is also a 45, 45, 90 triangle with the hypotenuse side being equal to 5 radical 2, then this side also must be equal to 5. And if that side's equal to 5, that side's equal to 5. And now, using our basic sentence, our primary principle here, the area of a rectangle equals length times width. We said the area of this particular rectangle is 5 times 10 or 50. And that's the area of the shaded rectangular region. So in this particular problem, we saw not only how to find the area of a shaded rectangular region, but we saw how to unpack and again how to really approach these problems that seem to be more difficult. Ask yourself again, what is the basic principle of this problem? Or what principles are they asking? Do you know that in order to unpack the information you need, you have to unpack those principles? So that's it for now. Good luck. And if I were you, I would try as many of these as possible. Again, looking for your basic principle.